Hello, everybody. Thank you for joining us for our second of the Dynamic Thinking webinar series. Again, Chad Chmura, Applications Engineer from CNC Software Mastercam. Today we're going to talk about the Mastercam Deburr Toolpath and how it's going to help us to increase our part quality as well as throughput of our machine shop with the technology that it alone offers. So I've opened up, this is Mastercam 2021. And we're looking at one of the sample parts that we cut in our machine shop. This is a race car bulkhead for rear suspension of a race car. So this part is kind of a lightweight airframe structured part where naturally there's going to be a lot of sharp edges that need to be deburred at the end of this process. And deburring really any part, it's time consuming. It's a leading cause of scrap. Anytime you have a human hand touching a part, the human hand is going to be inconsistent. The break edges will be different each time. And depending on how bad the part is, deburring these parts could actually be just dangerous. These sharp edges are not something you really want to be rubbing your hands along if you don't need to. So what Mastercam Deburr offers is a solution for breaking these edges. So we'll build a quick Deburr toolpath just to show you what it's all about. So under the multi-axis drop down, there is the deburr. And what this toolpath is looking for is a spherical tool. So it needs to be a ball or a lollipop mill. We can't use a chamfer mill for this because that would be a chamfer as opposed to a deburr operation. The really cool thing about this toolpath is how little it requires to get going and how really complex the results can be. The first thing we have to do is select our part surfaces. So what I can just do is triple click to select the entire body and selection. And then by default, the Deburr toolpath is going to detect every sharp edge on this part. And we have the option to exclude edges. So basically we say, oh, I don't want to deburr the edge where this bolt head is because we're not going to be able to reach that hole. So instead what we're going to do, for this case, we'll do a user-defined edge just so we can deburr one single edge. And if we just do a shift click here, we're going to get a chain that wraps around the entire length of this pocket. So this is a very simple pocket that needs to be deburred. So this is a very good first example. We enter our width or our depth of the break edge that we're targeting here. So this is a 20 thousandths, so it should be a pretty heavy, this is an inch part, so it's a pretty heavy break edge. The real power here is with tool axis control. So right now this is set up for a 3-axis machine. We have all sorts of options for running this with multi-axis machines. And then finally, we have some options for setting up some linking parameters and things. But right now, we're just going to leave all this as entirely default. So let's generate this with the default parameters. So really, I only entered, and I didn't even enter it, I left it default, but the break edge size. All we had to do was select surfaces and edges to deburr. So the point of selecting the surfaces is that this toolpath is consistently checked for collisions. And so what that means is that there will, no matter what you do, you will not find a gouge in your part. You will just have a good deburr toolpath, super smooth, very predictable, and you will not gouge your part. So if, as we'll see in one of these next passes that I create, this toolpath is intelligent enough to avoid any surfaces that are not requiring deburring. So we can see here inside the tool that we're just taking a nice 20 thousandths break edge, and we come off the part and retract to our default linking parameters, which ended up a little bit high, but that's okay. We can dial that in as we go. So, and this right here you could have done with a simple 2-axis contour toolpath. If I just copy this toolpath down, just to save some time on selection, and now let's do a different edge. Let's unselect this first edge. And now we'll select one that's a little bit more complicated. Again, shift click, we'll find all the tangent edges. And you'll note that this one is going to basically going to end tangent to a face that doesn't require a deburr, right? So this cylinder that sticks up is something that we don't want the tool to interfere with. So once this finishes generating here, and now this is still a 3-axis toolpath, and we're still using a lollipop mill. So what we're going to do once this is done generating is change the tool up a little bit, just to show some of the collision checking capabilities that we have here. So this toolpath comes in, just misses that surface, and immediately gets into deburring. So now it's a 3-axis toolpath, right? So this is something that you couldn't really do with a contour as you approach over these more complicated edges here. And again, come off the part with a nice retract. So let's say if, and again, just for the sake of comparing, we'll copy one more time. Let's say we don't have a lollipop mill. Let's say we actually have this ball end mill, which is actually a decreased or an increased shank diameter relative to the cutting diameter. Change that tool and leave everything else the same. What we're going to see is the shank of that tool needs to be collision checked against the cylinder that's standing up. So as we regenerate this toolpath, what we're looking for is that the shank of the cutter is going to miss this area. And so while this is going, we'll mention the next step of this is that we are going to add a little bit of multi-axis tilt, because with an increased shank diameter, we need the tool to stay away from this feature, which means we're not able to deburr all the way to the end of this part, right? Right now we're obeying a value that was set in our toolpath, maybe of something like 20 thousandths of an inch or so of a collision checking distance between the shank of the tool and the feature that stands up. And you can see the comparison between both of these toolpaths is that our new toolpath does not quite complete this break edge. So what we can do here is simply go into tool axis control if we have a machine that's capable of tilting, and switch to 5-axis mode. Right now we're going to keep the tool fixed to the main axis as long as possible. So this is going to make the tool stand up straight unless it has to tilt. Right now, as I mentioned, we have a 25 thousandths of an inch collision checking tolerance on the shank of the tool. So as this completes, we'll regenerate this. It actually looks like we do have a question here. The first question is so we're inside of the multi-axis toolpath gallery here. The first question is this toolpath available for users who have a traditional mill license? And currently that is not possible. This toolpath, even though up until this one I've been running with a 3-axis tool axis control, it is still a multi-axis toolpath that requires a multi-axis license to use. So it doesn't need to be run on a multi-axis machine, but your Mastercam license does need to be multi-axis. So if we look at how this tool approaches now with 5-axis mode, we get our tilt, a nice approach that keeps the shank of the tool away from the feature, and then it returns to straight as soon as it can, because this is our main axis that we want to remain fixed to. And then finally, the tool kicks over so that it is able to reach the very end of this chamfer. So this is, again, if you have a 5-axis machine, you're able to get the most out of this toolpath. Let's say, though, you don't have a 5-axis machine. So let's say here for our second operation, we flip the part over on the table, and we're now going to be using the top plane. Something that's really cool about the Deburr toolpath is the ability it has to create undercut deburrs. So now again, we'll go in with the lollipop tool, select our triple click to select the entire part. And just for example, we're going to say we want to define a single edge right here that we're going to deburr. And should just make sure that this is going to run in 3-axis. A little bit too late, so we may see a multi-axis version first. which will still be entirely functional. But I just want to show the ability here of this toolpath to run with 3-axis undercutting, because for somebody who just has a 3-axis machine, deburring a feature like this from above was never really possible. So not that it wasn't possible, it took a lot more work than what we're about to see here. So 3-axis, let's just do a quick regenerate on this. So that was a 5-axis toolpath, which meant it was doing a little bit of tilting. So that's something that we wanted to try to stay away from for this one specific case. So as this regenerates, so right now one strategy that we could actually employ here is, and the reason why this is taking so long to generate, selecting the entire body is maybe not the most optimal thing, because essentially that means that the tool is being collision checked against surfaces that are way out here. The really smart thing to do would be to select all the local surfaces. That way you collision check against surfaces that are nearby and save yourself a lot of time toolpath generation wise, not collision checking against unimportant surfaces. So here we see this super easy to create undercut back burr with the lollipop tool with a safe entry into material, safe exit off, and then the tool is able to retract up and away. So this, we actually were able to deburr this entire part with one operation per setup. So basically with this setup here, we would deburr every single sharp edge that is on the top of the part, flip the part over, do the secondary operations, and then deburr that whole entire side. So let's say if we have a case now where we've got a part on a dovetail fixture in a multi-axis machine, and we want to deburr this in one shot. So let's go deburr. We have, again, a lollipop tool here. Now, this is actually a part that we make for a Formula SAE team, and we make it actually every year. So the first year that we were able to introduce the Deburr Toolpath, the quality of this part increased immensely, because we would never deburr the holes where this drill feature goes through all these individual profiles. We would never deburr those. Those would be like a little hand file thing. So now with the Deburr Toolpath, I can come in and say, okay, I want to auto detect, just deburr everything. I just want to exclude everything on this bottom face, right? I don't want to deburr any of those because those edges are a bit of a reach. Everything else though, every sharp edge, I would like to be deburred. Another option that we have is 3+2 axis. So 5-axis simultaneous is going to allow for a lot of multi-axis motion, which is really cool. It's great for getting into difficult places, but the motion is pretty complex. And as a rule, with a 5-axis machine, we don't want to move any more axes than we need. So 3+2 axis, what this is going to do is basically lock to an orientation for as long as it can and deburr as much as it can before repositioning it in maybe a different orientation. So I think, again, we'll leave all our linking default. So I just want to reiterate just how simple this process was. We really only have to say we want 3+2 axis, deburr this part, avoid these edges, and this is the width of my deburr toolpath. And this one may take a second or two longer because we are actually deburring everything. So let's turn up our multi-threading manager just to make sure that things are moving. Seems to be. And so yeah, as I mentioned before, we would never reach inside of these edges. And the first time that we did this, we were able to get all those edges deburred, and these parts came off looking really nice. So we actually have one more part I'm going to show you quickly, just to show you what the actual output of a toolpath like this is. It really cleans up a part, and it gets rid of those inconsistencies that are created by a human hand touching your part. And actually, while this is generating, let me just pop the image up here that I'm talking about. This is a different part, but it's not going to show, is it? Mastercam's taking up all my power. Well, we'll let this toolpath finish generating and then show that picture. it did generate a little quicker than this before, and I just realized I didn't set, one thing this toolpath does have is tilt limits, so we can say we want to keep this thing tilted between, 0 degrees and 45 degrees or something like that. So it looks like we were given something pretty good. Let's just kind of hide some of these retracts. It looks like we have a pretty nice deburr here, which again, so what was that? Maybe a 2-minute generation time. And what we're going to have here is a toolpath that you can see here. It finds an orientation, stays 3-axis for as long as it can. It even gets down underneath this edge here. Finds a new orientation, finds a new orientation, and every single edge is deburred. Even here, we've got a little bit of an undercut, but we're still creating that nice 20 thousandths break edge without any gouges. And of course, for me, the most important part is once we get into these, we can deburr the ins and outs of all of these holes, where before we would have to make false geometry with the multi-axis toolpath and really kind of trick Mastercam into breaking these edges. So this toolpath has absolutely changed the way that we make this part, and the quality of this part has become something to be much more proud of. So actually, here's the image I was trying to show before. So this is an optical mount. This part was done in stainless 17.4. And this was a much smaller break edge than what we're showing in these parts here. But these break edges are all just enough to get the sharp points off, and really just enough to really kind of clean up your part and basically help you to maybe complete a part in a single setup, take that part off the machine and have something that's entirely finished and not in need of any post-processing whatsoever. So this part was cut actually in Mastercam for SOLIDWORKS, and I just want to open up the machine simulation for this quick, just to show a little bit more of how this motion looks at the machine. This is probably going to be a little bit choppy for you guys viewing. The GoToWebinar is going to be a little bit rough, but you'll see the motion anyway here. Which this was done with full 5-axis mode turned on. So we can see the 5-axis tilt simultaneous, creating just this beautiful little break edge everywhere. And this part we actually ran, we had just picked up a brand new Makino 5-axis machine in our shop. And this was the first part that I had ever cut on the machine. We had brand new tool holders, brand new everything, tools. This was all a Mugi partnership, so these are all a Mugi tools. And the Deburr Toolpath worked flawlessly, but there are some areas of this that were a little bit scary, just because, in order to reach some of these features, the tool had to really get in deep. I'm not sure how far away from those features we are here with the machine simulation. Should be coming up relatively soon here. We're going to see the tool holder actually dip right inside. Here we go. Here's one of the scary parts. But it always avoids those surfaces. And we were able to deburr the back sides of these holes through the part without any intersections anywhere. There's no gouges. We ran this with 100% rapid, and it was scary, but it worked beautifully. So here's another one where we're down inside the part. And I don't know even any human who could deburr this edge consistently. And yet alone, here we are with the Makino getting beautiful 5-axis deburr motion. So this Mastercam Deburr Toolpath is an extremely powerful tool for getting finished parts off your machine in essentially one clean, easy setup. And really, that's about as much as I wanted to show as far as technical content here. I'm kind of hitting my time limit. So is there any questions anybody has? Got a little bit of just jump into a PowerPoint again here quickly, unless anybody wants to jump in and ask any questions. We have one question here. Are we able to deburr a part in a single operation? And yeah, we just did that over here, where really this whole part, as long as you can access it, you can deburr every single edge of this thing in one operation, where before, this may have been 15 operations that you had to create some sort of fancy trickery to make a deburr toolpath. So yeah, you can absolutely get the whole part in one go. So just to cap this off, if you're not yet a Mastercam user and are interested in this toolpath and everything else that Mastercam offers, visit mastercam.com, and you can click this Find a Reseller link that we're pointing out here to get in touch with a reseller and mention that you saw this webinar and that you were interested in Mastercam Deburr for a multi-axis license. If you are already a Mastercam user, all three of these files actually live on our Mastercam Tech Exchange. So if you go to community.mastercam.com/tech exchange, you can download all three of these parts. And there's machining video that is accompanied with these things. You can see how this looks on the machine with actual videos. So definitely go ahead and do that. So here's a quick little screenshot of what the Tech Exchange looks like. So here we can download this part file. This is a lot of fully programmed parts that we machine in the applications lab at CNC Software. So definitely get out there if you get a chance.